Electron is on the pad at Launch Complex 1, and we are counting down to our final launch of the year, a dedicated mission for Synspective. Hello and welcome to Launch Day. My name is Muriel Baker and I'm a Senior Communications Manager here at Rocket Lab. And along with Catherine, we'll be taking you through the count today as we go to space for the 58th time.
Thanks, Muriel. My name is Catherine Chen and I'm a Flight Dynamics Engineer in the Space Systems team. It's great to be joining you for our 16th and final launch of 2024. In just 17 minutes, Electron will be going all the way up to deploy a single StriX spacecraft for our mission partners, Synspective, a Japanese Earth observation company. Liftoff is scheduled for 3:17 local or 14:17 UTC, and so far we're on track for an on-time launch.
Now, unfortunately, yesterday we stood down from our launch attempt due to an out-of-family sensor reading, but we are back today and ready to go to space. So today's launch will be our 6th mission for Synspective out of a total of 16 missions that they have booked on Electron. Our first launch for them was in December 2020, and we are proud to have been the sole launch provider for their constellation to date. So it's an honour to be back on the pad for them once again this morning.
So those of you with a keen memory will have noticed a distinct theme running through all of our Synspective missions to date, and that's the fact that they all reference owls. Our first launch for Synspective was dubbed The Owl's Night Begins, and we followed this up with The Owl's Night Continues, The Owl Spreads Its Wings, Owl Night Long, Owl for One and One for Owl, which of course brings us to today, Owl the Way Up.
So what is with all of the owls? Well, Synspective's satellites go by the name StriX, which is a genus of owls. And with at least 10 more Synspective launches on the books, this is far from the last owl-themed mission that you will hear about. Now, today's mission will deploy a single StriX satellite to orbit, which is what we call a dedicated mission. And this puts Synspective in control of their launch schedule, their orbital parameters, and other mission specifics that allows them to tailor the launch precisely to what they need.
Inside Electron's fairing is that single StriX satellite for Synspective. It's joining 5 other satellites in orbit, all launched by Rocket Lab to form a synthetic aperture radar, or SAR constellation. So SAR satellites can observe the Earth's surface in any weather condition, day or night. They're also unaffected by cloud cover, making SAR ideal for infrastructure planning, persistent monitoring, and disaster assessment. Example use cases could include detecting anomalies in road, rail, and energy infrastructure, resulting in lower maintenance costs and accident risk, or enabling the persistent monitoring of maritime traffic, border activities, and other potential security threats. Here's more from the team at Synspective.
Right now, the next StriX satellite is around 12 minutes and 15 seconds away from heading to space. So let's check in with the launch operators in mission control to confirm that everything remains on track and to listen into the go, no-go poll for today's liftoff.
To all stations, LD on mission core proceeding with go, no-go sequence. Stage.
Stages go.
Avionics.
Avionics is go.
GNC.
GNC is go.
VCON.
VCON is go.
T1.
T1 is go.
GC.
GC is go.
PLS.
PLS is go.
RSO.
RSO is go.
MET.
MET is go.
MM.
MM is go.
LD sub.
LD sub is go.
Copy all and final check mission control to North Pole. Please confirm the airspace is clear and there are no convergence with the center sleigh.
Copy LD, can confirm no convergence with St. Nick. Reindeer not yet airborne for deliveries, and the North Pole is green for launch.
Understood. Go, no-go sequence complete. We are T-minus 11 minutes, 2 seconds and counting. We are go for terminal count. Auto sequence starting at T-minus 10 minutes. From this time, the 3-word hold procedure is in effect.
That is confirmation from the LD, our operators, and the North Pole that we are go for today's launch attempt. Right now, the T0 is set for 3:17 NZT or 14:17 UTC.
So today's launch is our 58th overall and our 16th mission for 2024, which beats our previous annual launch record of 10 missions that we achieved last year. Now, this mission is also taking place just 7 days after our most recent launch from LC2, which lifted off on the 14th of December and was our third launch from Virginia this year. So while it's not quite the 2 launches in 24 hours that we demonstrated last month, today's launch still represents a rapid turn between launches, especially from 2 different hemispheres.
While launch often gets the attention, we are, of course, an end-to-end space company, so launch was just a part of what kept us busy this year. We also completed production of twin spacecraft for a NASA Mars mission, successfully supported the team at VADA to re-enter a capsule used to manufacture pharmaceutical products in orbit, made big progress in the development of spacecraft constellations for government and commercial customers, and, of course, took some big leaps forward in neutron development. It's hard to sum up a year's worth of progress in just a couple of minutes, but here's a tiny snapshot of what kept us busy this year at Rocket Lab.
What a year. And 2025 is shaping up to be even bigger across all of our programs. So if you want your next year to look just like that, why don't you join the team? Check out the careers section of our website for all of the latest open roles. Before long, we'll hear today's launch director, Paula Teres-Serralonga, count down from T-minus 10 seconds. Now, just before we hit 0, all 9 3D printed Rutherford engines on Electron's first stage will ignite. And then 2 seconds later, the hold-down clamps that keep Electron tethered to the launch mount, they'll release. And that frees Electron to take to the skies at exactly T0. Now, those engines will burn through the liquid oxygen and the kerosene stored in Electron's first stage until we reach depletion at around 2.5 minutes into flight. At that point, we're on the edge of space and we no longer need to carry the dead weight of the first stage with us. So we shut down those 9 Rutherford engines and the first and the second stages will separate. Electron's first stage will return to Earth, while the second stage, that is propelled by a single vacuum-optimized Rutherford engine, continues on to orbit, carrying the kick stage and its payload, the StriX satellite.
At around 3.5 minutes into flight, the protective fairing covering the satellite will separate. From here, StriX will be exposed to space in preparation for deployment. The second stage has the longest burn time of all Electron stages, with that single Rutherford firing for almost 7 minutes to take us from the edge of space to orbital velocity. Along the way, we'll conduct a maneuver unique to Electron called battery hot swap, but we'll go a bit more into detail once we're in flight. The second stage's job is complete around 9 minutes after liftoff. Its Rutherford engine will shut down just seconds before Electron's kick stage separates, carrying the StriX payload. The kick stage and its payload will coast around Earth for about 42 minutes before the small Curie engine on the stage ignites to maneuver into a circular orbit and deploy StriX to its new home in space.
Before we get to liftoff, though, we have to enter what is known as the final count. So at T-minus 2 minutes, Electron's flight computer will take over the countdown and autonomously run through final operations. Liquid oxygen will continue to flow into Electron all the way up until T-minus 1 minute and 30 seconds, and then Electron's first and second stages will be fully pressurized and ready for launch. Now, with greens across the board and the launch operators go for launch, all that remains is to wait for completion of that final auto sequence, and then we are on our way to space. So let's listen in now to Mission Control.
The vehicle is 40 on internal power. AFTS is green, enable for flight.
LOX load is complete. System is in recirculation. Anti-geysering is disabled.
Stage 1 and Stage 2 tanks are pressed for flight.
High flow engine purge enabled.
T-minus 20 seconds and counting. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1.
Beginning pitch over.
Stage 1 propulsion is holding nominal.
Our 58th Electron is headed all the way up to space carrying a satellite for Synspective. We are now 42 seconds into flight and we've cleared the pad, fast approaching max Q, or maximum aerodynamic pressure, the moment in flight when Electron experiences its peak structural load. Now the guidance, navigation and control team monitors that milestone, so let's listen into mission control to hear their call out that we have cleared it.
And reach 7-2. HVB discharge is nominal.
Cleared max Q.
And just like that, Electron has successfully cleared max Q. We're now at 19.9 kilometers in altitude and traveling at over 2,800 kilometers an hour with those 9 Rutherford engines burning strong. Up next, in quick succession, we'll see main engine cutoff, or MECO, stage separation, and then second stage ignition. All 3 events take place within seconds. Electron's first stage will then return to Earth while the second stage will continue the mission onto orbit. Let's listen in for those calls.
30 seconds.
$15 seconds to staging.
Entered burnout detect mode.
MECO confirmed.
Stage separation confirmed.
Stage 2 ignition confirmed.
There we go. Successful MECO stage separation and second stage ignition confirmed. Now, Electron's vacuum-optimized Rutherford engine will continue to burn for another 7 minutes from here, taking us all the way to orbit. And then up next is a milestone called fairing separation, or fairing jettison. And this is where the 2 halves of the protective carbon composite fairing that covers the satellite on the way to orbit splits apart and falls away to expose the payload to space.
Fairing jettison succeeded.
There we have it. Fairing jettison has been successful.
Guidance is nominal.
Now, Synspective's 6th satellite is exposed to space in preparation for deployment. Now, with just 5.5 minutes remaining in the second stage burn, we're at an altitude of over 127 kilometers. The second stage burn will be complete at around 9 minutes into the mission, so we have a few minutes remaining here yet. Now at T plus 4 minutes 18 seconds into the mission, having just ticked over 10,000 kilometers per hour, we are above 163 kilometers from Earth and on our way to space with the second stage of Electron burning bright, as you can see there, coming up to our next milestone, which will be the battery hot swap.
Our 58th Electron mission continues to track nominally 5 minutes into flight as we prepare for battery hot swap. The Rutherford engine's fuel is pumped electrically rather than fed by a traditional gas turbine, and we use batteries to power those fuel pumps. Once we deplete one set of batteries, we jettison them and swap to a fresh batch to reduce mass on the way to orbit. Let's listen in for the battery hot swap call and keep your eyes peeled to see the silver glint on screen as they fall away.
HGB discharge nominal, approaching hot swap in roughly 30 seconds.
Throttling down.
Battery jettison confirmed.
Hot swap successful.
A fresh battery pack is now in place and battery hot swap has been successful. All that remains now is SECO, or second engine cutoff, when the Rutherford engine on Electron's second stage shuts down in preparation for kick stage separation. We're at 6 minutes into flight and that SECO is scheduled for just after 9 minutes, so just a few minutes to go.
Stage 2 propulsion holding nominal.
Electron's second stage engine nozzle continues to burn bright as we approach now T plus 7 minutes 22 seconds into the mission. The trajectory is on track and we are only a few minutes away from payload deployment. Now we'll hear a couple of call-outs related to this. The first will be SECO for second engine cutoff to confirm that the Rutherford engine has stopped firing. And then next we will have the stage separation, and that will be confirmation that the third stage and its payload have been cleanly separated.
T plus 8 minutes and all is continuing healthy and nominal for Electron. Keep an ear out for the call from the operators declaring that we've entered burnout detect mode. So that means that the Rutherford engine is throttling down ahead of SECO, officially completing Electron's journey to orbit before kick stage separation. You'll hear that call soon.
SECO confirmed.
Stage 3 separation confirmed. Nominal transfer orbit achieved.
Welcome to Orbit. That's a successful shutdown of Electron's second stage, and the kick stage has cleanly separated as planned, carrying the StriX satellite on board.
The kick stage and StriX now enter a coast phase for around 42 minutes. And once they're at apogee, the kick stage's 3D printed Curie engine will ignite and complete the final leg of the mission, which is payload circularization and then payload deployment. So with that, we'll let the kick stage enjoy its tour around the world while we take a break, and we'll see you back here for payload deployment soon.
Welcome back to our 58th Electron launch all the way up, a dedicated launch for Japanese SAR constellation operator Synspective. Electron lifted off successfully at 3:16 local time and after 9 minutes of flight deployed a kick stage with the Synspective payload attached to a nominal transfer orbit as planned.
For the past 40 minutes, the kick stage has been coasting around the globe to reach a precise apogee in preparation for a final engine burn ahead of payload deployment. Now, that burn will be carried out by the Curie engine, which is a small but mighty 3D printed engine produced in-house by our team. Now, we've got a Curie nozzle right here, actually, so you can see it really is a tiny engine, but it packs an efficient punch on orbit to give the kick stage that final nudge to a circular orbit. Now, it's a particularly useful engine because it's realizable, and that gives us the ability to do multiple burns on orbit to deploy several satellites to different orbits on the same mission by performing orbit raising and orbit lowering maneuvers. Now, today's mission calls for one circularization burn to deploy one satellite and then a second burn to lower the perigee afterwards. So let's listen in for the call that the Curie ignition has taken place.
Curie ignition confirmed.
That's the call we want to hear from Mission Control. The Curie engine has successfully ignited and the orbit raising maneuver is underway. This burn will last about 2.5 minutes, placing the kick stage into a precise orbit ready for payload deployment. We will be listening out for the Curie shutdown confirmation, followed very shortly after by successful payload deployment. So let's pass it back to Mission Control.
Curie engine cutoff confirmed.
And that is a
Target circular
successful
orbit achieved.
shutdown of the Curie engine. So Synspective satellite is now all the way up in orbit and now just around 45 seconds away from deployment.
Payload deployment confirmed.
Welcome to Orbit StriX. Once again, we've delivered mission success for the team at Synspective. Electron has now deployed 6 satellites to orbit for Synspective, and we look forward to many more missions together in the weeks and years to come.
Since this is our final mission of the year, let's do a quick recap of the numbers for 2024. So today's launch was our 58th mission and our 16th of the year, beating our previous annual launch record of 10 missions in 2023. And now we have deployed more than 200 satellites to orbit on Electron.
That's right. So, most of this year's launches took place from LC-1 in Mahia, our private orbital launch site, but we also conducted 3 missions from LC-2 in Virginia. It's a great feeling to deliver another record year, and we can't wait to build on this with even more Electron and HASTE missions in 2025, and we're especially excited for Neutron's debut launch too.
For now, though, that is a wrap on today's launch coverage. Thank you so much for joining us as always. And from all of us here at Rocket Lab, we wish you a wonderful festive season.
Stay tuned to our social media channels for mission updates on the next launch. And until then, for the final time in 2024, this is Rocket Lab Mission Control signing off.